Good evening, students. I hope I am audible. We'll continue with the geometry portion that we were doing in last class. Okay, as usual, I will share the link to the notes in the chat so that those who are joining for the first time. Am I audible? 1 minute. Can anyone unmute and let me know?
Yes, you're audible.
Just a second. Uh, I shared the link to the notes. Let's continue with today's class, lecture 8. Try this. Find the radius of the circle given in the figure. If it is given that the area of the red and blue shaded regions are equal.
Excuse
This
me,
is
sir.
the
Were
yeah.
there classes before this? Because in the mail it said that it starts at 7th, on 7th December.
So these classes have been going on as a uh, bonus to the AMC registration. You can go through the previous notes. I think the recordings of these classes are available on YouTube. But there is no theory as such that we are covering. We are just doing questions, and from those questions, you will be exposed to new theory. Is what is happening.
Okay, sir.
Okay. So the question is find the radius of the circle given in the figure. If side of square is 2 and area of blue regions, blue and red regions are equal. Mean each of these red are equal to each other as well as to the blue region. Square and circle share the center, share a common center. Okay, so once you get the answer, you can send it on via the meeting chat.
So the 2 is centimeters or
2 is units, so doesn't matter. You can just give answer in dimension just units. Misrab, you need to find the radius of the circle. Uh, that is a tiny step. If in case you have found some other quantity, then just convert it to the radius of the circle. If anyone has any suggestions how to proceed in this, we can have a little bit of discussion while getting to the answer. Misbah, not correct. Try again. Om, not correct. Abhay, go ahead.
Is it 2?
No, answer is not two. Also, if you get an answer, send it in the meeting chat so that others, in case you are correct, then you have revealed the answer, right? We'll give others also some more time to solve. Okay, here few stuff that you can keep in mind is area of circle is equal to pi r square. Area of square is a square, where a is the side length. Okay, and what else? We have been given that this blue region has the same area as this red region, although the figure is not to scale. Okay, someone has given an answer. Abhyuday, there is one error in your answer that 2 should be inside and in the denominator. Just check once. You might have done some error. The side of the square is 2. Okay, so can we sort of say that the circle and square both are of similar size? So the diameter of the circle is also close to 2, which means the radius is close to 1, approximately 1. But answer is not exactly 1. What I'm asking is the exact value. So leave pi as it is. Okay, you can leave pi as pi in your answer and you can leave it as it is. We can divide the square and circle up into multiple regions. Using that, we can get to some conclusions. Okay, let's call this region 1. I'll shade them also a bit properly. Okay, Abhay, very good. That is the correct conclusion. From that, figure out the radius. Okay, so what we see is, if we want the area of uh, this red region, what we can do is we can take this entire circular region. This region of a circle bounded by 2 radius and 1 arc is called the sector of a circle. Okay, that's the definition of such a region inside a circle. It's like a pizza slice. Any pizza slice is effectively a sector because we can assume that all of the cuts have been made through the center. Okay, that would mean that we have 2 radius, and this sector region we can consider as our starting point, and we can remove this triangle. Let's call this triangle region number 2. So what we are doing is sector minus region 2 is equal to red region. correct? The other thing you can keep in mind is, suppose someone made a square pizza and made such cuts. Let's call this region a kite, because it effectively is a kite. These are two radii which are of equal length, and these two lengths, from symmetry, I'm just claiming that these two will be of the same length. So this over here is a kite. What I'm going to claim is kite minus region 1. Let's say that we are talking about this kite and this region 1. Kite minus region 1 is equal to blue region. Does anyone have a Abhay, close to the answer? It's not correct. If anyone has any doubts over here, unmute and ask. I'll go through the solution once again. What I'm trying to do is, from this big sector, I'm trying to remove this triangle, which is region 2. From this kite region, I'm removing another sector region, region 1. Okay, this is not a triangle, this is an arc. So this will be a sector which I'm removing. Now I'll equate red and blue regions. So what I end up getting is sector minus region 2 is equal to kite minus region 1. Now I can bring this negative area to the other side and this negative area 2 to the other side. What I end up getting is sector plus region 1 is equal to kite plus region 2. Now give some attention to what was the sector and what was the kite region that we were initially talking about. This big region is the sector region that we are talking about. To that we are adding region 1, which is another sector region. So two adjacent sectors can be combined simply. Okay. I hope this is completely clear. We are talking about this complete area, which is a complete region enclosed inside our circle. That entire area is equal to this region, this kite along with region 2. And this is just 1/4 of both the circle and square if you look at it closely. Does that seem plausible? We could do the same for these other regions also. Basically, sector plus 1, region 1, and kite plus region 2 means we have 1/4 of circle is equal to 1/4 of square region, square area. So we can write 1 by 4 pi r square is equal to 1 by 4 a square, which is 2 square. And we get directly r square is equal to 4 upon pi, which gives us r is equal to under root of 4 upon pi. So here the task was not to actually calculate and give the answer, but to get a sort of general appreciation of such kind of stuff can be calculated. Usually the options that you might get for such questions is under root pi upon 4, under root 4 upon pi, under root of, there might not be a root, there might be a 3 upon pi, there might be a pi upon 3, such kind of stuff. All these values are very close to 1. Correct. And that was the sort of idea we had initially also got from this question. Correct. Okay. The square side length is 2. So the circle seems almost as large as 2. And if we are asked the radius, it might be half of the side length. So answer must be close to 1. And that is where the options might be also. Okay. Any doubts? Anyone wants to discuss anything more? Anyone has any query why I directly did this 1 by 4? I can go over that also. Yeah, but go ahead.
So can't we just get to know that, like, so if you minus the red region of all the red regions of the square, it will equal to if you minus all the blue regions of the circle. So we'll
Correct.
get to know like that also now. If that's
Correct.
good.
You could say that this entire enclosed region that is made up of these triangle and sectors together, that entire region you can add and subtract on both sides. I mean add on both sides and you'll get a circle and a square. So you basically get circle square is equal to circle. That is also a way to go. Fine. If anyone wants another way to look at this question, basically you could take this entire figure. Uh, let's copy this. Let's call this inside region 1. So blue equal to red, blue plus 1 equal to red plus 1. Blue plus 1 is already a square and red plus 1 is a circle. You could go piece by piece and try solving it also, but this is also a simpler way to again look at the same thing. Okay? If you are able to understand it this way also, good. And if square is equal to circle, I'm talking about areas only. So directly now we have 4 is equal to pi r square. R is equal to under root 4 upon pi. Okay, we'll move on to the next question. Try this. Inside a rectangle, few points are marked. Not inside, on the rectangle. Few points are marked such that this is of length 3, this is of length 5, length 6, length 4, 3, 5, 6, 4. Okay. And we join these points on the sides of the rectangle to get a shape inside the region over here. Then what we do is we drop a perpendicular from uh, this line segment to this line segment. Find this length L. Okay, find L. I'll name the vertices of our rectangle and these points. A, B, C, D, E, F, G, H. If M should be given. If L is the length of line segment perpendicular to EH and FG, find L. ABCD is a rectangle. After 1 or 2 minutes, I'll give a hint regarding the question. Arnav, not correct. Try again. You're close to it. Or yeah, you are close to the answer, but try to figure it out. Acha, root 61 is not the answer. So I don't know how you are getting that answer, but try again. It's not correct.
I had gotten the same answer.
Uh, root 61 is not the answer. Okay, what did you try? Let's see. So that some
Sir, I tried to
others.
use Pythagoras theorem.
Okay. Where exactly did you use Pythagoras theorem?
Sir, by
In
Pythagoras
what
theorem,
triangle?
like we can conclude that EFGH is a rectangle.
No, EFGH is actually not a rectangle. Think about it. This angle and this angle are like complementary angles, correct? If
Yes,
this
sir.
angle and this angle were complementary angles, then this would be right angle, correct? But that's
But
not the case.
sir, in the triangle FDG,
Hmm.
we can use Pythagoras theorem to
This is
get
not
the side length.
SDG.
Sorry, it's parallelogram. Sorry, sir.
Yeah, this is a parallelogram. That is the hint that I was going to give. Uh, it's obviously a parallelogram, correct? Because these two side lengths are equal to each other. These two side lengths are equal to each other, correct? No, 61 is not the length. Square root of 164 is also not correct. Let's give it one more go. Answer is not an integer, okay? But answer is rational. So that is one more. Okay, those who have joined just right now, we're on the second question of the day. There is a rectangle ABCD. E, F, G, H are points on the sides, and they divide the sides into the given lengths. Find the perpendicular distance between EF and EH and FG. Misbah, not correct. Try again. Misbah, what did you do? You want to share your method? Yashraj, not correct. So again, we have discussed so far that this inner quadrilateral is not a rectangle because this angle and this angle are not complementary. These two are, sorry, in case you know similarity, these two are non-similar triangles. Okay, because this is of side length 6 and 5, 4 and 3. These are not similar to each other.
Sir,
So you don't have, yeah, no?
sir, if we draw a diagonal of ABCD, will it be perpendicular to the
No,
parallelogram?
perpendicular to the parallelogram in what way?
Will
To the
like the
sides? To
angles,
the sides of the.
yes, sir.
No, no, it won't be. In fact, for general points H, E, F, and G, they are not necessarily perpendicular. See, diagonals are fixed, right? You could have kept E and G's like this also. Some random line that could pass through it. See, the angle is changing for all such F and G points, correct? So it could be perpendicular sometimes, but it's not necessary that it will always be perpendicular. Okay, what is the, I'll give one final hint. Uh, Area of parallelogram can be written as height times base. Correct? That's twice the area of a triangle because a parallelogram is effectively two triangles. Uh, this is the hint. Find L. I don't know. I think you might have done some calculation error. Abhyuday, correct answer. Arnav, just check your calculation once again. Om, not correct. Although you are very close to the answer, you might not have done calculation properly. Uh, Hem Darshan, try again. Yes, that's correct. Okay, those are just joined late. Uh, this was the first question that we did in class. If you want, take a screenshot of it right now. Try it. Those have already gone through question one. No, no issues. Keep working on question two. Vaibhav, try again. Acha, can someone tell me what is the, those who have not yet answered? What is the area of this parallelogram? Can someone calculate that? Because that is the area of parallelogram I'm talking about. Uh, Once you get the area of this parallelogram, which is the height times the base of the parallelogram, you can easily figure out the height of the parallelogram. That is this length L.
So please show the previous question once.
Previous question. Abhay, not correct. Arnav, correct. Very good. Vaibhav, good. Vaibhav, if there's a decimal point, then it's correct. Sorry,
Yes,
no,
sir.
no. Vaibhav, the thing is, over here, okay, I'll start solving this question. The area of each of these regions, I'll copy this figure. See, the area of each of the regions in the figure is 6, 15, 15, sorry, 6, 15, 6 and again 15. Everyone agrees? Because half base into height gives us the area of this region. Half base into height gives us area of this region. Half base into height gives us another area. All these triangle areas are now known. Area of the rectangle fully is going to be 10 times 8. This is equal to 80. So this gives us the area of the parallelogram inside to be 80 minus 30 minus 12. This gives us 38. Independently try calculating this. Above now you see the error and the solution also simultaneously. So you get the area of parallelogram being 38. You have side length EH already known because it's the hypotenuse of a right angle triangle. This will become 5. Answer is equal to 38 divided by 5, and that is 7.6. Okay, Keshav, I hope you understood.
But I'm confused.
Okay, Abhay, yeah, what's the confusion?
Why do we do divided by 5 again?
Because see, area of parallelogram. Let's look at how a parallelogram actually looks like. It's like a rectangle, and then you like move it to the left. Uh, this is the height of our parallelogram. You could just take this triangular region, cut it out of this, and paste it over here. Why can we do that? Because this height over here will be the same height everywhere, because rectangles have the same height, correct? I mean, these two are parallel lines, so the perpendicular distance between both these lines are going to be the constant always. You can take this region, cut it out, and paste it below over here. So it will start looking something like this. Correct. And this over here is now a rectangle. And rectangle area is by definition how we start defining area as the product of two perpendicular sides. Correct. So I was this the confusion, or was something else the confusion?
No, I understand why we get the area, but why do we divide by 5?
Because this phi is the side length. The side length phi, or this side length is phi, correct? Phi times L is equal to 38. So L becomes 38 upon 5.
Oh, so this the one like on the wait, this is like the one. So there's a parallelogram. The right part of that parallelogram is that also another parallelogram.
Uh, which is another parallelogram?
So
This
there's
one?
that main parallel. Yeah, that is that also a parallelogram.
No, that is not a parallelogram. This will be a trapezium only because we have two parallel sides. But we are not individually removing the area of this region. Na? This entire parallelogram has height of L if we consider this as the base.
Oh, okay. So yeah, got.
Correct. So we can drop a height anywhere along this parallelogram. Okay. Try the next question, everyone. We have a right angled triangle with circular arcs drawn on each of the sides of them. Semicircles are drawn on triangle ABC. Certain quantities are given. For example, uh, diameter.
So are these all semicircles?
Yeah, all are semicircle. All
Okay.
circular, all curved arcs are those of a semicircle. First thing. Second thing, uh, we have area of, I'll write it below over here, or I'll write it inside over here. Area equal to 8 pi. Also, we have length of arc equal to 8.5 pi. Find the radius. Okay, so each of these texts refers to the quantities of these respective semicircles. Okay, so the area of this semicircle is 8 pi. The length of this arc is equal to 8.5 pi. You have to find the radius of this semicircle.
Sir, is anything
Mm.
given about the triangle?
No, triangle, nothing is given except for the fact that it's a right angle triangle.
Okay, sir.
If anyone has any confusion, just unmute and ask. Arnav, not correct. I think you have done some typing error. Just check once. Misbah, not correct. Okay, so the radius of this bottom semicircle will be a rational number. So if anyone is getting pi in their answer, that is unfortunately incorrect. Arnav, correct answer. Great. Okay, Arnav, you can take this 3D geometry question. Try to solve it in the meantime.
Sir, is my answer correct?
Just a second. Yashraj, not correct. Try again. See, Yashraj, we have been given different quantities everywhere. So, in one place, the area is given, area of semicircle is given, okay? And then length of this arc, which is the half of the circumference, is given to be 8.5 pi. Use that to find the radius of this region. Abhyuday, not correct. Both of you have found the same answer. So, what did you guys do? T7.
Sir, you're not audible.
No, I'm not saying it. So I think mistakenly you have figured out that AB should be root 32, which is false. Or you have also done some error finding AC.
Sir, is my answer right?
1 second. Keshav, not correct. Abhay, not correct. Okay. I think one of you had found the answer. Arnab. Arnab, are you there?
Yes, sir.
Okay, just a second. I'll take this question. 1 second.
So could you scroll up a little bit?
Just a second. Okay, so question number 4 is find ratio of shaded region to side face to one face to that of one face.
Sir, is it correct now?
Just a second. Okay. This is the question. Yashraj, very good. Abhyuday, very good. Correct answer. Both of you can keep working on question 4. Question 4 is saying area of this shaded region. Okay. These I point is the midpoint of HD. Similarly, J point is the midpoint of FB. We make a or we make a region which is a two-dimensional region. Okay, I'm giving you that. This is a 2D region. Find the ratio of this shaded region to the area of one of the faces of your cube, namely this or this or this. Okay, A, B, C, D, E, F, G, H is a cube over here. Those who are still working on question 3 can keep working on it. Arnav, it will be I, I I mean try to reason that for yourself. What will it be? After some minutes, I'll give a hint.
Sir, is my answer correct?
Yashraj. Just a second, I'll just confirm. Correct. Try again. Arnav, correct answer. Vaibhav, correct answer. Who else? Arnav, correct. Vaibhav, correct. And Yashraj, try again. Okay, so the hint over here is that this is a rhombus and not a square. This shaded region. Okay, first I'll solve question number 3. Question number 3, anyone wants to discuss? Those who have not yet found the correct answer. What is the method you are applying over here? Anyone wants to discuss? Abhay, you have found the diameter. BC length you have found, but you have to find the radius. So that will be half of
7.5.
whatever you have found.
Okay.
So here we have been given the area of this semicircle. Area of semicircle is equal to half times pi r square. So
Sir,
this
please
gives
go and
us
show the question.
question 4.
Yes, sir. Thank you, sir.
Uh, so I'll write it with a different colored pen. Uh, answer equal to blue. So what we can do is half pi r square is equal to 8 pi because that's the area. From here we get r is equal to 2. Correct, because you can multiply the 2 inside over here. So this entire length becomes how much? Am I doing an error? Uh, r equal to 4, sorry, r equal to 4. R equal to 4. And so this entire length AB becomes 8. Again, over here, length of this arc is half of the circumference. So that means half of 2 pi r, half of 2 pi r is equal to 8.5 pi. From that we get r is equal to 8.5, or this entire length AC becomes 70. Now since this is a right angle triangle, you can use Pythagoras theorem to figure out BC. BC is equal to square root of 17 square minus 8 square. And in case you have seen a few Pythagorean triplets, few examples are 3, 4, 5, 5, 12, 13. Then you have 7, 24, 25. Then some that don't follow this exact pattern, where you have like the sum of these two is the square of these numbers. You can deviate from that a bit also. You can write 9, 40, 41. Another way of going about doing this series is uh, 8, 15, 17. This is the first of this kind, where you have uh, the sum of these two becomes 32, which is half of the square of 8. Okay, so it's like 17 square minus 15 square is 17 plus 15, 17 minus 15, which is 8 ka square. So if you even solve it, you get 289 minus 64, which is equal to under root of 225. So this length becomes 15. And since 15 is the diameter of the region we want, answer is equal to 7.5. Now again, this seems like too messy. In case anyone has doubt, I will repeat once more. No, very good. That is a general formula. Okay.
Do you show the next question?
Next question, yeah. Question 4. We have a cube with us. Now in this cube, we are joining point E to the midpoint of side FB, joining J to the J again to C, and the C to midpoint of side HD, and then E is joined to I. This forms a region called a rhombus because all these side lengths are equal, and it is given that this is a 2D figure. Okay, there is possibility that any 4 points in space, when you join them, they don't form a 2D plane. But here I'm just letting you know that it is a 2D plane because these two sides are actually parallel. These two sides are parallel to each other. If that situation happens, then it is guaranteed that this is a two-dimensional figure. One example where you don't have a 2D figure is, suppose you have a tetrahedron. Think about this. Uh, a tetrahedron, there is an angle between these two faces, correct? That is called that is called a dihedral angle. Angle between this plane and this plane. If you want to visualize this, this is a tetrahedron that I'm talking about. There, if I join or try to make a region with these 4 points, it doesn't become a 2D shape. Here it is a 2D shape, it is a rhombus. Now you have been asked that find the ratio of shaded region, which is this rhombus, to that of one of the faces of the cube, which is any of these.
Sir, was my answer correct?
Second. So Yashraj, it will come without x, correct? So without write the answer without x. Still, I think there is some error. Just try to rectify it.
Sir, for rhombus also it's side square. The area side square.
No, no. For the rhombus, that's what the entire point of this question is, to try to figure out what should be the area of a rhombus. So I'll give
Half
you
Is
diagonal
it,
into
is it the
diagonal.
product of the diagonals?
yeah, it is product of diagonals, but you have to multiply it by half. Okay, so area of rhombus equal to T1 D2 by 2. Okay, try to think why this should be correct. Uh, First of all, one key fact about rhombus is or rhombi is that the diagonals of a rhombus are perpendicular to each other. Okay, that is quite easy to show. Okay, if you join one of the diagonal, you form an isosceles triangle. The perpendiculars drop to this point are the median also. This line. I think this is simple stuff only, right? For an isosceles triangle, from the vertex, if you drop a perpendicular, that happens to be the median also. That happens to be the angle bisector also. And if it is the median, that means these two have been bisected. Similarly, this perpendicular drop also lands at the same exact point, and this is a straight line. So you can say that both of these are diagonals and they are perpendicular to each other. And what happens then is that the area of rhombus is product of the diagonals and you divide it by 2. Because you could fill up this entire region as a rectangle. You can see that this is the height of one rectangle, this is the base of the rectangle, and all these are half of the entire rectangle region. Correct? So if you want to directly use it, product of diagonals divided by 2 is the area of rhombus. Yashraj, correct answer.
So this formula will also work for squares, right?
It will also work for squares. And that is the beauty in this question. You can get to the answer quite much quicker uh, than you would expect. Square is a rhombus because square has all sides equal. Square is a special case of a rhombus. Obviously, they're not correct. Try again. Okay, who all are remaining to solve? Anyone giving it a try? Just write wait in the chat, or else I'll solve this question and give another question. Fine, I'll give you another question. Till then, those who are remaining can keep working on question 4. There are two squares. Just a second. Okay, I hope the figure is understandable. Area of small square equal to 4. Area of large square equal to 5. All right. Uh, Find the product of A and B. Find AB.
Sir, is my answer correct?
Just a second. Keshav, which question?
My
Keshav or
answer is for
Abhay?
the fourth question.
Fourth question. You can remove a lot of the common stuff. Keshav, try again. I don't want decimal result. Just leave it as exact figure with the roots and everything.
I put it
Arnav,
in
just a
roots
moment.
only. I put it in.
Abhay, you can simplify it a lot, right? I think the answer is correct only.
But sir, it'll be very hassle getting the decimals.
No, is this what you have written? Just a second. Uh, Arnav, I'll come back to you. Just a second. So, is this what you have written? Root 32 plus root 48 upon 2.
Yes.
But you can simplify this na, into 2 root 2 plus uh, 2 root 3.
But how do we do that?
Because 32 is equal to 2 to the power 5. This is equal to 2 to the power 4 times 2. And you can then split it into 2 to the power 4 times root 2. So that becomes 4 times root 2 or 4 root 2.
Okay.
Correct? Similarly, root 48 can be written
Sir, is
as
my answer
2 to the
correct?
power 4 times 3. Just a second. So this becomes 4 times root 3 or 4 root 3. Okay, you do a little bit of practice, you'll be able to get through it quite quickly.
Okay.
Yashraj and Arnav, correct answer. Very
Can you show the upper question?
good. Where were we? Question 5. Okay. I'll give one final sixth question, which I'm not discussing right now. Find the area of a hexagon of having same perimeter, area of a regular hexagon with same perimeter as that of an equilateral triangle. With side of with side with area, sorry,
Sir, is my answer correct for fifth question?
with just a second, with area 4. I'm now going to just take a screenshot of question 6. I'll go sequentially solving question 4, 5, and then 6. Right. Vaibhav, Abhyuday, Abhay, Yashraj, all correct. Keshav, try again. Rest or Keshav, question 4 ka answer correct. Okay. I'm starting with question 4. So here, JI, this distance is actually the face diagonal. Correct, because it's the same as the length between HF and BD. All these are parallel lines. They are joining the same height points across both of these lines. And since this is a rectangle, all perpendicular lines going through it like this will have the same length equal to BD. So JI equal to BD equal to root 2 S or root 2 A, where A you could name the side length. Alright, this is the first result. Second, CE is equal to the body diagonal, or it's the length between this farthest two vertices of your cube. And if you try to figure out the length of that, that will become under root of a square plus a square plus a square, that is equal to root 3a. Alright. So we have the length of one diagonal, we have the length of another diagonal. Now answer will be equal to ji times ce divided by 2 divided by squares diagonals, which can be bd times ac. So bd times ac divided by 2. These are two diagonals of our squares. Now, obviously ji and bd were equal because that is how we had defined them. Ji is equal to bd and they are root 2a. AC and CE remain to be calculated, and or just to get plugged in over here. We have this equal to root 3a upon root 2a, because AC is the other diagonal of our square, which is the same as BD. So we get root 3 upon root 2 or equal to root 6 upon 2. Abhay, for which question? Question 6. You don't need to use Heron's formula, although you could. This is an equilateral triangle and a regular hexagon. So both their formulas is a general result. You can try finding it out right now if you want, or you could use Heron's formula also if you want.
There is my answer for the
Okay.
sixth question, correct?
Sixth question, Yashraj, not correct. Try again. Okay, coming back to question 5. In question 5, this is a very, very famous looking figure, correct? One square inside another square. This is actually a right triangle, correct? If this is of length A, this is of length B, which makes this under root A square plus B square. So what we have with us is that square of under root A square plus B square is the area of small square, which is equal to 4. And we have A plus B the whole square is equal to 5. I hope everyone agrees with this. This is a right triangle. So we have one side as A, another side as B. It is known to us that the hypotenuse will be square root of A square plus B square, or the area of this entire square will be 4, and that will be A square plus B square. So we have two quantities, A square plus B square equal to 4, A square plus 2AB plus B square equal to 5. From here we get 2AB equal to 1, or AB equal to half.
Is my answer for question 6 correct?
Question 6. No, correct. Very good. Okay, I'll give 2 more minutes for it. Any doubts in question 5? No doubts. All right. Question 6. We have a regular hexagon.
There is my answer, correct?
Just a second. Yes, that's correct. Very good. And you have another equilateral triangle. P equal to P, or perimeter equal to perimeter.
So what's the
Keshav,
formula for finding a hexagon's area?
hexagon, you can actually divide it into multiple equilateral triangles. Correct? Because this I have not drawn the hexagon properly, but if you join the opposite vertices, all the opposite vertices, if you join them, you will end up getting the center is equidistant from all the sides, correct? And it turns out that this is 120 degrees which gets bisected when you actually draw each of these diagonals, the longest diagonals. So you end up getting 60-60 degree angle triangles, which are equilateral triangles, correct? There are 6 equilateral triangles inside your regular hexagon. Use that to find the area of this regular hexagon and area of equilateral triangle. You'll get the answer. Abhyuday, not correct. You just need to find the area of the hexagon. Okay, I'll solve it. Let's assume the side length over here is B. Side length over here is A. Okay, so area equal to root 3 upon 4 A square. In case you were not aware of this formula, you could derive it using Heron's formula in case you know that. If you don't know, no issues. The proof is simple. You can find the height of your equilateral triangle. And this also comes from Pythagoras theorem only. Again, this is a general fast proof for it. This is side length A. Your equilateral triangle has altitude, median, and angle bisectors all coincident. They are all the same. So this can be written as A upon 2. Using Pythagoras theorem, you can figure out this length as A square minus A upon 2 the whole square. And you get root 3 upon 2A. If you already didn't know this result, then this might seem very fast and confusing. Although I would urge you to go and like read up on this somewhere. You can, internet is at your fingertips, right? You can search for height of an equilateral triangle, you will get all the results. Once you know the height, which is root 3 upon 2A square, multiplied by the base, which is A, and divided by 2. So you get half base into height, area of equilateral triangle, root 3 by 4A square. Now there are 6 equilateral triangles inside our regular hexagon. So here area becomes 6 times of root 3 upon 4 B square. Now it is known that 6 times B is equal to 3A, or B equal to A by 2. So in the end, we can just substitute the value of B inside here. So we get area of X equal to 6 root 3 upon 4 times A square upon 4 upon area of triangle, that is root 3 upon 4 times A square. You can cancel off a lot of the stuff and you're left with 6 upon 4. Now the area was known to be 4. Correct? This was given in the question with area 4. You can use that fact directly and get that area X equal to 6. Sorry. Okay. At this point, I will share the class notes again. So just wait for a minute while it loads. Any doubt so far in today's class? Anyone, if they want to discuss, I can do that. Notes are available in the meeting chat. You can copy it, paste it, keep that with yourself, because I'll be continuing in the same notes. So far, 8 lectures have gone by. If you have missed them, no issues. You can try to solve the questions. If you're not able to solve them, no issues. Try to Google up similar questions and try to understand the working and then reattempt them. Okay. See you guys next week. We'll be having same class next week also, hopefully. Bye everyone.
Yes,
Hi, sir. Good evening.
Hi, sir.
yes, sir.